Welcome dear students. Today we shall be discussing pulping. Pulping is a fundamental process in the paper industry that involves the conversion of wood or other fibrous materials into pulp, a crucial intermediate in the production of paper and paper products. In this lecture, we will explore the various pulping methods, their significance and environmental considerations associated with pulping processes. The history of pulping is closely intertwined with the broader history of paper making, both of which have ancient origins. Paper making began in ancient China around the 2nd century BCE with the use of plant fibers such as mulberry bark. The practice spread to the Islamic world by the 8th century and eventually reached Europe, where paper mills were established in the 12th century. Rags served as the primary fiber source until the 19th century when Louis Nicholas Roberts' invention of paper-making machine in 1798 marked a significant advancement in efficiency. The 19th century also saw the development of mechanical pulping for more energy-efficient processes, while Carl F. Dahl's 1884 patent introduced the kraft pulping process, enabling high-quality pulp production. Ongoing technological advancements continue to shape the industry with a focus on innovations in pulp processing, bleaching methods, and energy efficiency. Students, now let's delve into the topic of pulp feedstocks. The pulp consists of woody materials that have been defibered by biological, physical, and/or chemical means. The pulp and paper industries mostly use wood as a feedstock due to its improved specific properties for making paper. However, there are diverse non-woody sources which can be used as cellulose sources such as sisal, rice straws, cotton linen, sugarcane bagasse, pineapple, and straw. In terms of physical structure and chemical composition, wood and agricultural residues are quite heterogeneous and differ based on environment, age, geographic location, species, etc. Wood is classified as softwood or hardwood, with the former having longer fibers, which makes it a suitable feedstock for pulping. Students, now we will briefly discuss the different types of pulping methods. The two primary pulping methods are chemical pulping and mechanical pulping. Each method has its unique characteristics, advantages, and applications in the paper industry. Chemical wood pulping involves the extraction of cellulose from wood by dissolving the lignin that binds the cellulose fibers together. Chemical pulping methods are typically more selective in removing lignin compared to mechanical pulping, resulting in higher quality pulps suitable for a wide range of paper and paperboard products. Chemical pulping involves three main steps. The first step is preparation. The wood undergoes a peeling process and is then cut into chips. Subsequently, the material undergoes filtration to eliminate impurities, ensuring that raw materials are relatively clean with uniform sizes and specifications. This preparation sets the stage for the ensuing physical and chemical reactions during the cooking process. The next step is pulp cooking. Pulp cooking is the fundamental process involved in the conversion of raw materials into chemical pulp. This entails placing the materials along with a precise amount of chemicals into a digester. The successful execution of this process relies on precise control of temperature, pressure, and time. During this stage, the chemicals infiltrate the raw material, engaging with a chemical reaction with the lignin present. As a result, the individual fibers undergo a loose separation, forming what is known as brown pulp. In cases of a robust cooking reaction, some lignin may dissolve from the second wall of the fiber, and other components like carbohydrates, resins, and inorganic salts may be partially removed. Consequently, the pulp produced through this chemical process typically contains a high cellulose content. The last step of chemical pulping is purification. Following the pulp cooking process, the coarse pulp undergoes purification before being utilized in paper making. Pulp purification typically involves three main stages: pulp washing, pulp screening, and pulp bleaching. Pulp washing is the initial step that separates the pulp from the cooking waste liquid. To achieve this, 3 or 4 vacuum drum washers or pressure washers are commonly employed. In pulp screening, coarse chips and fiber bundles are removed from the washed pulp. This process utilizes screens and various types of hydrocyclones to eliminate heavier impurities like sediment present in the pulp. The process of pulp bleaching is to reduce or eliminate residual lignin in the pulp, along with chromophores, the primary colored material in the pulp. This is done to achieve a higher whiteness. Commonly used bleaching equipment includes the disc filter, twin roll press, single screw press, etc. Now let's take a closer look at different types of chemical pulping methods. The two main types of chemical pulping methods are kraft pulping and sulfite pulping. The kraft pulping process is a full chemical pulping method which uses sodium hydroxide and sodium sulfide at a pH above 12, temperature of 155 to 180 degrees Celsius and steam pressure of 800 kilopascals as the main cooking conditions to break down wood chips into pulp. The kraft process is the most used pulping method globally because of its advantages of producing paper of high strength, ability to recover energy and chemicals during pulping, and the ability to utilize both hardwoods and softwoods as raw materials. Kraft pulp is mainly used for making high-strength boards and packaging materials. The sulfite pulping process is a process that involves cooking wood chips at high temperature and pressure in a digester with an aqueous solution of sulfur dioxide, calcium, sodium, magnesium, or ammonium bisulfite. The sulfite process breaks down the wood by dissolving lignin and cleaving lignin bonds through the formation of sulfonate functionalities. Unlike kraft pulping, sulfite pulping is suitable for wood species with low extractives like tannins, polyphenols, pigments, and resins, as these interfere with the pulping process. The sulfite pulping process tends to produce pulps of different types and qualities with a wide range of applications, since the sulfite cooking liquor can be used within the entire pH range. The main advantages of sulfite pulp over kraft pulp are brightness, easily bleached pulp, easily refined pulp, higher yield, and production of pulps that forms less porous sheets. The disadvantages include low pulp strength, nearly impossible chemical recovery, long cooking cycles, and only softwood species can be pulped. Sulfite pulping processes are distinguished into three categories according to their pH, that is, acid sulfite, bisulfite, and alkaline sulfite. The acid sulfite process uses calcium as a base. Acid sulfite cooking is carried out using a strongly acidic cooking liquor to avoid liming up conditions in the cooking digester. The pulp temperature is kept within a range of 125 to 145 degrees Celsius and the cooking time is up to 7 hours. Due to the acid digestion conditions, the resulting pulp is weaker and has low hemicellulose content. As a result, acid sulfite pulp is used for making dissolving pulp and tissue paper. The acid bisulfite process uses soluble bases such as sodium, magnesium, and ammonium and a higher liquor pH of 3 to 5. The temperature is usually kept between 160 to 180 degrees Celsius, while the cooking time is around 0.25 to 3 hours. This type of pulp produced is relatively strong and is used in making newsprint and medium-grade writing papers. The alkaline sulfite is a full chemical pulping process that utilizes a liquor consisting of approximately equal amounts of sodium hydroxide and sodium sulfite at temperatures of 160 to 180 degrees Celsius and a cooking time of 3 to 5 hours. The alkaline sulfite process produces pulps of similar qualities as those of kraft pulps. Chemical pulping has its own set of advantages and disadvantages. The advantages include high quality pulp. Chemical pulping methods, particularly sulfite and kraft, produce high quality pulp suitable for a wide range of paper and paperboard products, including fine papers. Selective lignin removal. Chemical pulping is more selective in removing lignin from wood fibers compared to mechanical pulping, resulting in pulp with desirable strength and brightness. Flexibility. This method of pulping is versatile and can process a variety of wood species, allowing for flexibility in raw material selection. Now we will discuss the disadvantages of chemical pulping. Environmental impact. Chemical pulping, especially kraft pulping, generates significant amounts of pollutants such as black liquor, which can have environmental consequences if not properly managed. Energy consumption. Chemical pulping processes often require high temperatures and pressures, leading to increased energy consumption compared to some of the mechanical pulping methods. Low yield. Chemical methods are generally less productive than mechanical methods. Cost. Chemical pulping methods are often more capital intensive and some mechanical pulping methods affecting the overall cost of the production. Non-selective. While chemical pulping selectively removes lignin, it can also impact the cellulose fibers to some extent, leading to a potential reduction in fiber strength. Now let's focus on the second main type of pulping, the mechanical pulping. Mechanical pulping physically separates fibers by grinding or refining wood, bypassing the use of chemicals to break down lignin. This process has been in use for centuries, with evidence of its use dating back to the 16th century. However, it was not until the 19th century that it became a widespread method of producing pulp for paper making. Mechanical pulping accounts for about 25% of wood pulp production in the world today. This volume is expected to increase in the future as raw materials become more difficult to obtain. Mechanical pulping, with its high yield, is viewed as a way to extend these resources. However, this method is energy intensive and yields paper with lower strength than chemical pulps. The mechanical pulping process involves several steps that are designed to separate wood fibers and produce pulp for paper making. These steps may vary depending on type of mechanical pulping process used, but generally include preparation. The logs or wood chips are debarked, cleaned, and screened to remove impurities. In debarking, the outer bark layer of the logs is removed. This step ensures that only wood is used in subsequent processes, preventing impurities and maintaining the quality of the pulp. Debarking is followed by cleaning, where dirt, sand, and other extraneous materials are removed from the debarked logs. This enhances the efficiency of subsequent stages and prevents contamination of the pulp. The cleaned wood chips are then screened to eliminate undesirable elements further. This process ensures that only suitable wood materials progress to the next stages of paper making. Grinding. The wood chips are ground into small particles using a grinder or a chipper. Refining. The ground wood particles are then fed into a refiner, a machine designed to mechanically separate and refine the fibers. Refiners use pressure and sometimes steam to break down the wood particles further, converting them into pulp. Screening. After refining, the pulp undergoes another screening process. This step is crucial for removing any remaining impurities, oversized particles, and unrefined materials that may have passed through the refining stage. Screening also helps control the size of the fibers, ensuring uniformity and consistency in the final pulp. This is vital for achieving the desired paper properties. Bleaching. The pulp may be bleached to achieve the desired color or brightness. Common bleaching agents include chlorine, chlorine dioxide, hydrogen peroxide, or oxygen. The choice of bleaching agent depends on environmental considerations, the desired level of brightness, and the type of paper being produced. Students, it's now time to discuss the types of mechanical pulping methods. There are 4 major mechanical pulping methods: stone groundwood pulping process or SGWP, refiner mechanical pulping or RMP, thermomechanical pulping or TMP, and chemi-thermomechanical pulping or CTMP. The stone groundwood pulp process is the oldest mechanical pulping method in which wood is ground into a pulp. It involves pressing a debarked block of wood lengthwise against a rotating grindstone, revolving at speeds of 1000 to 1200 revolutions per minute. The abrasion force of the grindstone tears wood into thin fibers and fiber fragments, which are washed away continuously from the grindstone by a water stream. The friction that develops in the grinding zone raises the temperature, which softens the wood, hence easing the fiber separation process. The slurry of the fibers and fiber fragments is screened to separate them from shavings and other oversized particles, and thickened by removing the water. The SGWP process produces high pulp yields, about 95%, because it retains most of its lignin. Generally, paper produced through this process has low strength, discolors easily as it ages or when exposed to light. This ground pulp is utilized in making low-grade products such as newsprints, magazines, printing paper, and low-cost grade packaging paper. The refiner mechanical pulp process encompasses shredding and grinding of wood chips between rotating metal discs or plates using a refiner at atmospheric pressure. Production of RMP is a two-stage process, with the first stage involving defibration of wood into individual fibers and fiber fragments, and the second stage involving loosening the fiber structure to increase fiber flexibility and fibrillation. The RMP process gives rise to a long fibered pulp which is stronger, freer, bulkier and darker compared to the conventional SGWP. The RMP process has undergone modifications and improvements to include thermo and chemical pulping pretreatments. Third type, the thermomechanical pulp process involves impregnation and preheating of wood chips with steam under pressure of 20 to 40 pounds per square inch and temperature of around 115 to 155 degrees Celsius, followed by refining. The TMP process is two-staged, with the first stage involving refiners being at an elevated temperature and pressure, and the second stage encompassing refiners being at ambient temperature and atmospheric pressure. The high temperature of steam softens lignin and enhances fiber separation with minimal cutting and fine fiber generation. Refining is carried out under the glass transition temperature of lignin, which is 140 degrees Celsius, where fiber separation occurs in the middle lamellae, layer of the cell wall. TMP is stronger than RMP and SGWP, although it suffers some reduction in yield. Due to its strength, TMP is used for packaging materials, catalogs, magazines, and is used as furnish in printing papers, paper boards, computer cards, and tissue paper. The fourth type of mechanical pulping process, CTMP, involves the impregnation of wood chips with a combination of steam and chemicals to soften the lignin before mechanical refining. The lignin softening chemicals such as carbonates, hydroxides, sulfite, and peroxides, and further pretreatment at higher temperatures break the wood structure apart and remove lignin. The CTMP uses less mechanical energy and chemicals to soften and fibrillate wood chips. The CTMP process is advantageous compared to TMP as it improves mechanical strength properties while maintaining high yields of 85 to 95%. Due to higher strength, pulp produced by CTMP process is used in making high-grade printing papers. Let's now go through the advantages and disadvantages of mechanical pulping. Advantages of mechanical pulping include cost effectiveness. Mechanical pulping is generally more cost effective than chemical pulping methods. The process requires less capital investment and consumes less energy, contributing to lower production costs. Higher yield. Mechanical pulping methods, especially thermomechanical pulping or TMP, often yield higher amount of usable pulp from a given volume of wood compared to some chemical pulping methods. Reduced environmental impact. While energy consumption is a concern, mechanical pulping processes generally produce fewer chemical pollutants than chemical pulping methods. The lower use of chemicals contributes to a reduced environmental impact. Recyclability. Mechanical pulp is well suited for recycling. Papers made from mechanical pulp can be recycled more easily than those from chemical pulp, contributing to sustainability efforts in the paper industry. While mechanical process has some promising advantages, it is not without its share of drawbacks. These include fiber damage. Mechanical pulping processes can cause some fiber damage due to the intense mechanical forces involved. This can impact the strength and quality of the final paper product, particularly in the case of TMP. Shorter fibers. Mechanical pulping generally produces shorter fibers compared to chemical pulping. While this is acceptable for certain paper grades, it may limit the use of mechanical pulp in higher quality papers. Limited applicability. the quality of mechanical pulp may not be suitable for all paper products, especially those requiring higher strength, brightness, or durability. For example, mechanical pulp is often used for newsprint but may not be ideal for fine writing or printing papers. Energy consumption. While mechanical pulping is considered more energy efficient than some chemical pulping methods, it still requires significant energy inputs, especially in refining processes. This can be a drawback in terms of overall environmental sustainability. Brown color. Mechanical pulps, especially stone groundwood pulp, can have a characteristic brown color due to the higher lignin content. This limits their use in applications where a lighter color is desirable. Students, we have now arrived at the conclusion. Pulping is a critical step in the paper-making process, shaping the characteristics of the final product. As the industry evolves, there is a growing emphasis on sustainable and environment-friendly pulping practices. Continued research and technological advancements will likely drive the development of cleaner and more efficient pulping methods, ensuring the longevity of paper industry while minimizing its ecological impacts. So dear listeners, with this we wrap up today's lecture. Thank you.